Alright, so I'm back. For any of you joining me, this is Evening Rust, and the first half of the episode tonight I was basically complaining about Rust, and we were trying to figure out a solution, and I think we figured something out so we can move on. And it looks like Ion Codes has been active while I was gone, so I'm just going to read through what he says. And the problem is when you apply the borrow to the parent, all structs by doing this. Bother. If self is now a child of struct infections, affection is not a parent, the compiler will borrow the infections as well. If you try to borrow another field in infections, it will complain because self was already borrowed. They depend on hacking. And yeah, I kind of understand why Code's saying, but in this case, I don't. Let's see what they have. I mean, I'm going to have to keep working this in Rust and figure out what the preferred way of doing it is. We're really sort of hacking around the logic we want to do. We have the logic, and we're really struggling to get that logic coded in Rust. Remove this. And so what we have is we have the solution now where the swap trucks, what's it going to do is it's going to call find move. Find move doesn't actually modify anything. It grabs the indexes it's supposed to move around, and then back and swap trucks will move them. And now we're going to do the same thing with find swap. It's a bit more code than the other approach, but it'll work. And so now we're going to say what we're doing. We're right here. So now we're actually swapping trucks for any two crates. Find any two crates between them, and let's find out if they're lower in that case. So truck heavy dot weight minus truck light dot crates L dot weight truck heavy dot weight. No, wait, this would be truck light dot weight now. Truck heavy dot crates P. Creates P dot weight minus self-weighted averages. And why are emulators so popular in Rust? I mean, first, are you guys doing it? Why are emulators popular, or is it just because I happen to stumble into the Rust emulator crowd that they seem popular? Okay, so good volume. We're going to do this light truck light dot volume. Okay, so that would explain it, yeah. I host him as well, so it's good. So he does emulators, so anybody looking for good Rust code should probably watch Varys' stream. He'll be much better at it. But we got him coming over to Coding Game. We'll see how he does that. I don't know if he's done any progress on that yet. I got him to sign up. We'll see if he actually comes back. And then we can compare algorithms, because eventually we're going to hit the same ones. And we can see if he does it better. And yeah, and I will point out, when you say this, can I point out that I am still learning Rust? The show is about learning Rust, and this is not indicative of the type of code I'd write in a language that I actually know. And so that's why we're struggling here. We're struggling to figure out the correct way to do it. And we will keep doing that until we find out the right way. Well, why not? That's good, that's good. Like watching people solve problems. Okay, so the first problem we solved was use Rust, and then we actually solved the problem. It's like meta problems, problem inception. Okay. So what this find swap is doing is we find swap between the two trucks, is I'm literally taking the n by n, so this is a horrible n squared algorithm. Take the two trucks and look through every crate, and if a swap of any of these crates brings them closer to the average weight, that's what this delta nu is doing. If delta nu is less than, I need a delta, is less than the delta, it means this resulting swap is better than the way it was before. So if we have, and the good volume means the swap has to result in the total volume of crates not exceeding the maximum. And so when we have this now, we return sum, and I guess it's going to be P comma L. That's a weird tupley thing. We'll see what happens there. Otherwise, we return none. And return none. And we do the swap trucks here as well. Nice one, iron codes. That's yeah. Okay, so we have some P comma L. I don't know how this works. We're gonna have to figure out this matching thing. I don't know how to put tuples into an optional, whether this is some P comma L or P. We're gonna find out right away. If it starts whining at us, it's gonna complain to us. This doesn't need a comma here, which I found kind of weird. And so we're going to move the crates in both directions, and oh man, this is going to be hard. No, we move this one first, and that should be okay. Add crate adds it to the end, so it's not going to modify the indexes. So we move the first crate, and I need to check that out right away. And so current crate, we're going to do this, read the signs again. So current crate, self trucks, the truck heavy index creates P. We do that. And then going to current crate is truck light index creates L. Index should not be perturbed by this add crate here. This remove it would be, so we just, if we do this in the right order, this won't be perturbed in the wrong way. Truck light index, truck heavy index, would create P, and this is going to be L, where it wasn't L. And so now we have find swap. Now we're going to play the compiler error game, and hey, there's no scroll bar, that's a good sign. 154. Abs max. I am missing a one there. There we go. Okay, 153. Ooh, right. We're gonna have to fix that too. Let's do it this way. I'm going to call it a heavy crate. This isn't actually the heavy crate, it's the heavy truck crate, but we're going to have it clarified. Heavy crates creates P, and heavy self-dot crates and current crate index. And we do the same thing over here for the light crate. It's overkill for coding. Well, I mean, if we're just trying to learn Rust, it won't be overkill. I mean, like, look, we're not even on the coding game website anymore. We're already doing this offline, and it's just because it takes too long to do it online. So truck light crates.l. This is going to be the light crate index. Although I'd really like to get it back to a game where there's graphics, because I want to see something every so often, because it's nice to actually see occasional graphics in the stream. Or we start writing visualizers, and maybe we can borrow Floris's code for Rust Boy, and we can start visualizing this in 3D. That would be fun. Okay, so we have heavy crate. Heavy crate.weight. Light crate.weight. Okay, we have light crate. Truck volume plus truck light volume plus heavy crate.weight.volume. Yeah, one file sucks, Jasper, I know. I mean, Camelpage, this is, what was it again? What font am I using? I am using Bitstream Verserif, sorry. Bitstream Verserif. Love it. Great for coding. And so this is a light crate dot volume. So it's P and L. It's not the crate index, it's the index into the trucks themselves. There is somebody pointed me to for Rust at least, there's a crate generator which patches a bunch together. Cancer, no, this is a wonderful font. Why would you not like my fonts? It's so nice. I mean, all right, have fun, Madra. Leaving for work. It's midnight now. It's, you know, so it's early in the morning for you then, I guess. We have 2 Muda files. That's okay. This one we can handle. We just stick these in blocks. And that should kill the borrowing. Alright. So, we did something. And our answer's slightly better. So we had 133, now we're down to 97. And the code we had before we did anything was 99, so this is actually an improvement. We're actually getting better. And how many, this is with 10,000 swaps. Let's, if I increase the amount, let's see if we get better now as well. No. Well, that's not nice. It's kind of disturbing that I don't get something better than that. Alright, this is really slow. 10 times as slow. This is like a really brute force type algorithm though. And we're in debug mode, which makes it super slow. Okay, this has been more than 10 times though. This bothers me. And we're not getting any improvement, which is really bad. So what do we get when we do just 100 swaps? So it does improve. Let's get rid of this -G so it runs faster for us at least. We're actually going to put the -O mode on here, -O3. Or is it just -O? And do 1,000. What does that give us more as well? Slightly. Okay, so we top out at 10,000. Any more than that, we don't get anything better. Which means our algorithm is going to have to be slightly cleverer than what it actually is. Because we're not getting any improvement there. And we should see probably something better in 1,000 as well. Now, part of the issue here is that I'll remove all this junk here. So let's go over what we have now first of all. We have these 2 swapping functions. We have a swap truck. As like, given we have 2 indexes, we're curious, do we actually... Yeah, Jasper, I know we're going to have to do that for the live one, for sure. But we're not doing... I'm just doing that for now because I actually want to see if we get improvement. And we're not getting improvement. The purpose of putting the fixed number in is that I can control and see how much of improvement I get. So I have the swap trucks function, and it does 2 different types of swapping. It first compares, can I move one from the heavy truck to the light truck, or can I swap between the 2 trucks? And these algorithms, from the movement from the heavy one to the light one, is fairly easy to do. We take one crate over, and we just iterate through all of it. We say, go through all the crates, and if moving it to the other one is going to make them both closer to the average volume, then do it. The swap one says, let's compare each crate back and forth. If any combination of swapping the crates gets us closer to the average volume, average weight, then let's do it. The issue might be way up here in the actual swap. Why did I have that again? Yeah. We're just iterating through the trucks. We have no particular order, so we're just taking one truck, and I wanted a random number, but we don't have a way to produce random numbers on Coding Game, and this is a real problem. I can't just take some random index and find it. So how do I do this? How do I actually do a better approach? Maybe I should just methodically go between all of the trucks rather than self.c plus that. Let's do a swap set function. Well, let's make swap a whole bunch. So we're going to do 10 swaps first of all, and I'll show you why. And this swap, we're going to go through the whole trucks first. So we're going to say we're going to do one whole pass of all of the trucks. So for I in 0.num trucks, the comp truck number is going to be just I. We said I, and this is self.next truck. If comp truck index equals prime truck index, continue. Otherwise, we keep going this way. And we swap them. And we don't implement the next truck. At the very end, we implement the next truck. So every time we go through the loop, we're going to go over one truck. Oh, that's frightening. We'll figure out how to do a random number generator later. Ours is going to be like the only code submitted with like their own random number generator on it, like a Messine Twister or whatever the new one is. Or maybe there's a crypto library on there. We'll find out. So this is going to be a lot slower, but this will guarantee we have good coverage. Now wait, assuming I don't make an error. Unexpected 103. Oops, I'm in the wrong window. Okay, forgot that. Okay, and it got worse. Option's nice, yeah. I know about option because in my own language, Leaf, optional is built in. It's not like a type or anything. It's a fundamental part of the type. And so we've done something horribly wrong. We've actually made things heavier in this approach. That's really curious. Right? So look at this. It's heavier now than if I just did no swaps. $133. Okay, so this is probably why we're not getting a better value, is because one of these swap things is making it heavier. So if we make yeah, we could probably do that. I could probably actually just take like a from any other programming language, emit a list of like 10,000 random numbers at a seed and just do it that way. Okay, let's do it this way. Which part of the swap is making us slower? So the moving swap works good. Moving works good, but swapping is bad. So move works, but swap is bad. So there's something wrong in our swap algorithm. Let's check this out. We have a truck heavy and a truck light. Delta heavy. So our current weight, this is the delta. The maximum delta this is how far we are away from it. So in truck heavy creates.len, I'm unsure about calculating delta this way, but okay, let's just finish this way. Heavy crate index, truck heavies creates P, heavy crate index. Good. That's the heavy crate. Now, in the light, we're going to go through all of the light crates. And it's L, light crate index, light crate index. And so this is an N by N comparison. A delta nu is truck heavy dot weight minus the heavy crate dot weight. That's right, we're going to get rid of this one. Minus the average weight. This is the delta. Dot absolute. That's correct. And then the maximum of... Oh, wait, but we have to add in the lightweight. That's correct. And we're missing a weight here. That's why it's doing it wrong. Heavy crate dot weight. Okay, so now we can actually do this. Truck light dot volume plus heavy crate dot volume minus light crate dot volume. I forgot it here as well. These are really long lines. They're actually not so long. Okay, it's 113, and it's going to be hard to fit into one screen. Minus heavy crate dot volume. Okay, so that should be a bit better. That'll stop making stupid mistakes. And heavy create. Where did I type that? And we're down to 76. This is really nice. So 76. This is a good progress here. The algorithm is really slow, but we do 10 sets of swap. This is 10 times num trucks. Just remember, this is times num trucks swaps. Which this is 100 trucks, so that's only 1,000 swaps. So 1,000 swaps, we're doing really well. So let's put this up to 100 and see where we get to. 20. That's delightful. I really love that. It improved a lot. Let's put it up to 1,000. Let's see if we get even better. Awesome. We're doing great. Can you cheer now? Yay, cheer, woo! That's a tiny amount. Let's see if I can push it even further. And we didn't get much of improvement in this last one. So that means we have room for improvement. But that was actually really good. That gave us a lot of improvement. And so we're going to have to, and this is where I want the randomness. Because the way I'm doing this now is, although random shouldn't help, because we've tried every single combination. What this means is that we're actually going to have to do some sort of 2 swap. Because this means is that because I try every single combination of trucks, there's absolutely no simple swaps left that got it there. And I'm wondering how we can improve that. But this would actually get us to the point. Let's remove this optimization and see how long this takes. Blah, 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 blah. Okay, this is going to be really slow. Alright, let's just run it over. I'm just checking for the 50-second thing. Wow, this is lots of fun. Okay, well, let's put it down to 1,000 and save it. Now let's go over to coding game and let it run over there. Let's play all the test cases first. .289, that's the one we had. That's our test case. And 116, we're doing not so bad. So our total is 530 right now. And it looks like our delta, depending on how many test cases, we could get close to the 1 limit. We might have to find 1 improvement. If we get less than 1, that'd be delightful, because that means we get to meet the senior bankers. And that was the whole purpose of the episode. We want to meet senior bankers. This looks good. Let's just submit this. This is going to take forever. Did our other one actually finish yet? No. Oh god. It's going to take a long time. And this is in debug mode, and optimized mode, as you can see, is exponentially faster. And I know how compilers work, so I write them. I don't do the low-level emission, but I absolutely know why debug mode is so slow. And so this is the old weight. Weight delta, 500. That can't be what we got this time. So where does it show our current score? Final score, 100%. This is not right. So we can actually get in touch now. We can get in touch with a banker, I think. This is showing the old value. This is kind of annoying, right? There we go. Look at that. Woohoo! We can meet a senior banker. Got it. So there we go. That's what I wanted to achieve today. We actually did really well. Our algorithm gets stuck though. So now we have to figure out, thanks Iron Codes. Now we have to figure out how we can get it to go better, because we're actually absolutely sticking. And we know the values, so I should check the leader. Let's see where we are. We're probably pretty far behind, but we broke the 0. And most people have here broken 0, so I'm just curious of where we stand. There's no, well yeah, there's no space in the name. So we're at 122, so even at 0.6. So I'd consider 1 to be the solve rate, but we're still quite far behind. And that's because we're stuck. Our algorithm, regardless of how many times we run it, is not finding better swaps. So how can we do that? What other swap do we need? A 2-bucket swap might work. Or one of our algorithms is being too restrictive. Okay, that's Euler-Schütz, that's what I was thinking as well. Right now I only do 1 versus 1. I do 1 and 0, I do a move, and I also do a 1 versus 1. So you're saying I need to do 2 versus 1 or 2 versus 2. That's awesome. Jasper not found. The reason why the timer won't work is because we're not finding anymore. This result here, this 289, was the exact same result I got with 10 times less swaps, which means increasing the number of swaps won't help, and we have to do a fundamentally different swap. Locally worse swaps are okay too if they don't ruin the global optimum. But how would I know that's okay? How would I know if a local swap is okay though, if it's not ruining the global optimum? So I want to check that first. I think I have a slight mistake in here. When I do this find delta, what I'm saying is I take but I actually don't know what my global optimum is. I don't know if you're watching Euler-Schütz, that I'm actually already swapping based on the global. I'm comparing everything to the average weight based on the fact that the leaderboard has zeros in there, meaning that the average weight of all these crates is the optimum. And so all I'm dealing with is local optimums. I don't care about the global optimum at all because I can never ruin it, and I actually don't have a basis for how to do the local one because all I have to compare against is the average weight. Unless what you're suggesting is that I shouldn't compare against the global, I should just attempt to make 2 trucks closer together? That's curious. Let's try that. Let's do the local average weight to be equal truck heavy dot weight plus truck light dot weight divided by 2 F64. Let comp weight, so I don't have to write this again each time, local average weight. And we'll compare it to the comp weight. And so what the suggestion, I guess, from Euler-Schütz is that we compare local weight. And I'm doing this first because the 2 versus 2 is going to be a bit more coding than just doing this. And it's because of the way we've done it in Rust that it becomes a bit of an issue with 2 versus 2, 1 versus 1. But we'll figure it out. And comp weight, where do I have comp weight? Comp weight, compare weight. So what we've changed this here too is that in this find swap, because we're going to assume this find move has stopped finding stuff after the first loop, and we might actually just stop doing find move entirely, because 1 versus 0 is silly. Knowing that we have to go to 1 versus 1, 1 versus 0 is probably just not worth the effort. But maybe it is. Maybe it catches stuff. I don't know. And so we're going to compare to local weight, and this reduces the local delta And I don't think there's any possibility that can ruin the global maximum. So we're just going to do this. This will make it a bit more chaotic. And we'll see what comes out of it. We'll leave it at 1,000 swaps for now. And we're going to switch it back to the optimized mode just so it doesn't take as long. 0.289. It did not find any more. But it got the same value, which is curious. No, so it's not finding any more, so that's not enough. But curiously, it doesn't make it any worse. It actually gets the same value, so you don't need to compare the global, you can just compare the local ones. But now we have to do the next step, as we knew this was coming. We knew we'd have to do like a 2 versus 2 now. And we just had to figure out how we do this very well. And wow, is there an efficient way to do this? This code is already getting very messy. Is there an efficient way to do a 1 versus 2 and a 2 versus 2 swap? I want to reuse this code. The code is very, very similar each time. What we really have is a move. We want to compare how many items we get in each one. And how can we actually do this in an efficient fashion? I don't mean efficient in speed, I mean efficient code-wise, because I don't want to do another fine swap that returns like 3 use sizes, then 4 use sizes. I prefer to just have variables saying how many items can I swap. And is that really just a matter of picking random ones again? That's hard to say. But the 2 swap definitely has to be done. Yeah, that's, I mean, now it's just all, just asking, when you create these virtual boxes, did you actually just iterate over all the possibilities, or did you just randomly do it? And the reason I'm not doing any randomness now is because there is no random on Rust on coding game. It's really unfortunate. So I have no choice but to do nested loops. And so this is going to be yet another nested loop. You test all possible. Okay, so you're doing the same thing, and you just do that down to 2. That's some pretty deep loops. No wonder it gives us 50 seconds to complete. And so, how can I do this in a simple way? Up to 4. Wow. Wow, that's a lot. 4 versus 4 is a pretty deep loop in comparing this stuff. And so that's apparently how we get up higher than that. Well, let's see if we can do a little bit better. We have... Codes, the reason I say is we tried rand last week, and it gave us the error saying the external crate wasn't there. If you can tell me the syntax, I can quickly try it again just by importing the crate. But I remember we tried it actually once. It should be available. Okay. Well, when we tried it, it wasn't there. "21 days ago, extern crate rand." Great. Let's see if it actually works. Alright, so it can actually work. But now, based on what Euler-Schatzal has told us, he's not doing random. He's actually just iterating all possibilities. But we may not have that option because we know we're in debug mode. And so, let's use rand. Let's figure out how to use rand. We should probably still iterate over all of the trucks and do them in parallel, but the iteration over all the trucks I think makes sense so that we never miss any combinations. The rand is going to come inside one of these moving things. And we're going to have to figure out how to do this. We're going to figure out... You take 2 random... Okay, so let's do random trucks approach then. Right now I'm actually going over all the truck combinations, and you take 2 random, so let's just do the random ones as replacements. We'll still do over num trucks, otherwise our value is going to be too slow. Okay. Let's do this. Let mut-comp truck index equals rand thread range dot gen. What does gen range do? Generate a value in the range? Num trucks. I hope this is a use size. It's going to be a use size now. Your 2U trucks. And the rest of the code should work, because if the same index, we just continue anyways. Otherwise, we swap them. Let's see if this actually works. Oh, not quite. Not fed in RNG, so we need to find a different way of doing that. We had that code open, rushed around here. Oh, I think there's a... Huh. It's a bit weird. String create rand. That's in their example. Well, look at their example. Their example is exactly what you gave me. Thread RNG. Thread RNG. Aha. Not found in rand still. Well, I saw this on Ferris's stream. Let's just do this. See if that does it. No. This is going to be an error. I can't use extern create rand. What does that mean, unstable library? That doesn't look good. How do I use an unstable library? Rust unstable library. Alright, so I don't know how to use rand still. We're still stuck with not knowing how to use rand. Which sucks. So, what do I do here? What am I doing wrong? Use rand RNG. Well, how do I fix that? I have an extern rand. It's saying unused. Unused, and it's unstable. And it doesn't know what it is. This is all they have here. Extern create rand. What's a toml? Let's create a toml. I don't know what that is. This is a crate.toml. Cargo.toml. What does that mean? How do I use a toml? So now I have a toml. Oh, great. I need a single file. I want a cargo. Ugh. Coding Game needs to fix this. Cargo's like npm, but they have rand installed. Yeah, but they have rand installed, so apparently if I have it installed locally here, I can use it. And it won't need the cargo file. As long as I can get it to build the cargo file, I can do this. Because that's what the link said. Wherever it was. So we had the extern create rand. They say it's supposed to work. Well, I can save it. I can see if it's actually working there. We just got to compile it over here. We're going to try it here. Yeah, okay, so it's totally happy on Coding Game. So I just have to get it running locally. So how can I just manually install this crate locally? Is there a way I can do this without the toml file? Obviously there must be, because they don't have one. So how do I get this running locally? There's got to be some way to do this. I don't want a cargo project, I just want a project. Okay. Well, let's do this. Make dir. All the files are here, so I'm going to call it. Okay, we're going to do this. We're going to move stuff around. We have a number 1 here. What does that mean? Somebody goes to this. Like, okay. What I'm going to do is in Coding Game, I'm going to back out of this first to kill the local editor settings. And we're going to create a new file over here. And I've lost you guys over here again. There we go. Make dir the great dispatch. Move the great dispatch.rs to the... Wait, no, we're going to go over here first and cargo create a file. Cargo, new, bin. What name do we want? Great dispatch. Come on, no, don't do that. Why is there a git file? Okay. There shouldn't be a git file in here. Why on earth is Cargo creating a git file? It's bad. Bad of it. Okay, we want to copy from the great dispatch.rs to source. Call it main.rs. And how do we run this? Cargo? Cargo run? I mean, that's a bit much. I'm okay with VCS and stuff, but to actually create the actual Git repository settings as part of the cargo crate, that's a bit much. Okay, so we need the dependencies now. So get rid of all of this stuff. And let's open a file over in, we have a great dispatch, cargo toml. What do we want? We want dependencies. And you want rand equals star, you said. Or put this, I'm waiting. Let's see if that works. No package or project section. What? It's finding the one in the higher level. That's really silly. It looked up the level for the cargo before it looked in the current level. I'm not in the wrong directory. I was in the directory we created, but it actually looked up a level and found it there. Hello? Why are you compiling libc? Okay, that makes sense, but okay, yeah, I can live with that. It has its own build system. Now I guess it's building. I no longer know how to combine stuff in the command line, though. How do I pass it optimization flags and stuff? Unoptimized plus young info. I'm sure cargo is fine. I mean, it's just confusing at first. What have I done wrong? Why is it taking so long? Something broke. Cargo run... Oh yeah, because it's waiting for it. So how do I do compile? Cargo build -- release. Okay, so what I want to do as well is I want to take the move // tgd test to test01.txt. Okay. So cargo build release and cat test.01 greater than mort-ora-y debug equals 1 to target / release / the great dispatch. 0.5. Okay, so the randomness got us quite far. That was fewer loops. Where's my source now? We still have to stick this all in one source file for now. We're doing 100 loops, so we're doing random ones. Let's see if we get better if we do more. So we're actually doing better without doing random ones. Wait, that's actually smaller. That doesn't make any sense. How does that actually get smaller than we had before? Because we tested all combinations before. Now it's testing all random ones. That's a little bit weird. We must have hit some sort of local optima before. Was the last one smaller than that? It was. So now we're hitting kind of local optima and stuff, and it kind of sucks. We can get rid of the seed stuff now, though, I guess. Don't need I. Don't need a seed. Okay, so we're actually doing better not doing that, but now we're going to have to find a way to swap multiple crates. So instead of doing the, wherever I did this num trucks, we're going to go back to the one that has, just goes through all the possibilities. Even though we had some things that were actually better without. And, or maybe we just do random. I don't know. Does the random number generator have a stable seed? If I run this again and again, do I get the same value each time? 3, 5, 2, no, I get different values each time. So if I input the number, it'd probably be better. So this is going to make it hard to compare. How do we know if we're doing better or not? Well, this one should get a lot better. So let's go back and let's just create the other function we need. Swap trucks. What we now need is a generic one. Find and swap. Truck light index use size seedable RNG. Yeah, but let's just leave it for now because we're expecting a significant improvement. We're expecting that point whatever to become 0.0 whatever. If we don't get there, then we're not going to improve. So we'll just take that. We have to get a magnitude better. Now this is going to become the real problem in Rust. How do I return little arrays that aren't totally inefficient? I need to return like a vec. Is this going to be horribly inefficient? And we'll assume these are... I thought you couldn't return slices though, because the ownership rules are wrong. We're going to be creating the vector in here. And unless we pass in the vector, well, let's worry about it first. We'll worry about optimization later, and then we'll just pass it in. Box. Okay, well, let's just worry about that after, and we'll stick stuff in. And now we want to just create, and we're going to create a bunch of random boxes for now. So how we want to do this, we're going to take truck heavy, truck light. Trying to think of just local average weight, delta. So we have the same find delta. And now we're just going to try a bunch of possibilities for I in 0 to... This is just to confirm that it works. No, leave me alone with the lifetime specifiers. I'm not going back to those. So what we need to do is we need to collect random boxes from both of the trucks. And so let's do it this way. In the truck, we'll create a function called get rand crates and self. And it's going to return a vector of use size. V equal vec new. And this is going to be V. Now we just have to decide how many crates we want, and Euler just said he tried up to 4, and he got up to 11, and we're not going to push that, so let's just say up to 4. And how do we create those random numbers again? Range. There's look like a good one. What'd I do? What'd I do? No, no. There we go. And what do you mean test each crate versus each other crate? I already do that in a loop. That's my current loop. My current loop is to test all the crates against each other. I'm just trying to set up the one now where I compare multiple crates to each other. And we're going to create 1 to 5. Yeah, but then I have to create a permutation engine as well. I want to test the random ones because the random one is probably faster, and at least it confirms to me whether this will work. Otherwise, I have to figure out how to actually do permutations in Rust if there's a standard library. I've done permutations so often, I don't like writing that code. So it's actually random choosing the code. If somebody knows if Rust has a choose function, this would be delightful. Let's check that first. If it has a choose function, we're going to do it that way, because choose makes this so much easier. And if I have to write choose, though, I'm going to go crazy. Turn a random element from values. No, that's not what I want. Is there a choose multiple? Well, choose is when you have a set of 7 elements, and it's actually permutations. I want to iterate over all of them. It's a selection. I want to iterate over all combinations of 2 from a list of 1 to 7. So if I have the numbers 1 to 7, I want to get the list of, say, all combinations of 2 of them. If there's a function that does that, then great, I'll choose that approach. Otherwise, I'm going to have to go implement that approach, and I don't want to do that right now because it's a bit of work and it's tricky code. I've done it a few times, but I don't remember off the top of my head how to do it because I never do. But if Rust has a standard way of doing it, it's usually in a combinatorial relation, combinatorics, permutations. If there's any kind of permutation, maybe permute, random combination. This search is useless anyways on Rust, so let's just get rid of it. Well, let's check both of these. Clinker, I'm worried about crates because there's only so many installed on Coding Game. But permutation sounds... That's exactly what I want, Ion Codes. Well, not this. I want combinations. If I can reduce the number of them. It's very, very close, but it's like, so if I had a set of 7, I don't want a permutation, I want combinations. So every combination of 2 from there. But it sounds like it's in the correct way, but how can I do this? So until we figure that out, we're going to do random ones. Unless you can find another one, I'm going to start working on the random solution. It is a combination. It's iterating over all combinations, and like 7 choose 2 is the common one, is the notation, whatever it is in math. I mean, like 7 and 2, I think, is the notation. And this counts in how many combinations of n2 do we have. And so now we're just going to do it this way. And let's see how we do this. And this is going to be terribly slow generating these random sets. That's why I prefer the combinations, because not only are we going to try randomly for random sample iter. That sounds good. No, I want rand. Okay, let's see what this is. It's not quite clear on what it does, but this sounds like what we want. Non-repeating randomly sampled elements. The order is not random. Okay. Why does it return 2 vectors? I need to check this first, see how complicated this is. I'm trying, if it's already in Rust, I can do it. Check something. Is this I'm just check the definitions. Yep. That's exactly it. Let's see if we can understand the code first. This is a lot of code I don't understand, but that's great. Then we can skip the randomness altogether. Yeah, I'm going to have to modify it. So do we continue with the random way first, or will we just do the combinations way? Let's test it first. Let's make sure we can get this working in some fashion first. And that's outdated code. Okay, so let's go with the random approach first. We're going to go with random approach first if we don't have that, and we'll come up with the randomized code otherwise. So random. So we had this sequencing thing. Well, let's do the random approach first because it should work. As soon as we can figure out what sample iter does, then we should be fine. Okay, so sample iter does sequence sample iter. Do I have to import that? Rand, range, and sequence, I guess. Let's make sure it works first. That's okay, Uncles. If you want, great. I would definitely use it. And remember, we're going to have to iterate over 2, so the combination of 2, but I think that's not a problem. We just have inner loops, as Euler-Chassel said. We just have one loop inside the other one. But that just means the function probably has to have a callback function. And it shouldn't be a big deal. Let count. Okay, where am I? 47. We'll do it the random way for now. I forgot that. Okay, generic. So it didn't complain about our input there. Okay, so we want 5.min self.crates.len. That's how many items we want. And then we want to say sequence sample iter. When return sequence sample, oh, we just don't have to return it, we just return this. Sequence sample iter. Where's my RNG? Just thread RNG. Is this like horribly inefficient to keep generating these things? I guess we're going to find out. 0.self.crate.len comma count dot unwrap, because it's never going to be an error. If anybody can explain to the docs, why is this docs showing to return 2 results? Vector T from. Okay, so this is the OK result, and this is the error result. I get it. And so we're just going to unwrap it. We're going to assume it's never an error, and it should never be a error. And so we get rand crates. Let's go down to our loop, our new loop, get end swap. And we want to get rand crates, and both of them we're going to do heavy crates equals truck heavy.get rand crates. Let light crates equal truck light.get rand crates. And can we just debug these somehow? Print line colon question. I just want to see that they work. Heavy crates. And we have to find this somewhere. We just return none. And let's put it first. We'll put this first. We'll just do this one first. Match self dot find end swap, because this is going to replace all of them. In the end, it's going to replace all of them. It may be a bit slower, but that's okay. Truck heavy index, truck light index. And whatever we do, just don't care. Because I just want to see this working. Wrong number of type arguments, option. Okay, so this has to be, yeah, okay, got it. This is a 184, where am I? This has to be a tuple. Could not compile, why not? Okay, I gotta do clear here, clear and cargo build. Found struct, expected mut. What? Weird. So these are all unique generators, which means this is horribly inefficient. That's not my problem at the moment. Cannot infer type T. Well, see, it's the problem when you get used to type inference if you can't figure out what it is. I should put it... And we don't even need that one, so... Those lists look good. Control C. And these are always... They're supposed to be in order. It's lying to us. The docs are wrong. Non-repeating randomly sampled elements. The order is not random. So the doc is wrong. Because this order is clearly random. 0, 4, 6, 3. And... it doesn't matter if it's random yet. It'll be an issue for when we remove stuff. But I think the docs are actually wrong, or they're not clear what this means, because it is clearly, the order is random. What do you mean the order might be the same each time? How can you have randomly sampled elements where the order is not random? I don't quite get that, but I can ignore that logic for now. And which we want. It does us what we want. It tells us which crates. And so now what we're going to do is wherever we call that, we have our generic algorithm, crates. And we're going to have to calculate these values, like how heavy these trucks are. And so we're going to add up all the heavy crates and all the volumes of the heavy crates. So we're going to say let mut heavy weight equals 0 F64, let mut heavy, and let's make a function for this. Heavy weight, heavy volume equals truck heavy dot some crates. Well, let's not put it part of heavy truck because then we have to pass stuff. Self.sum crates, self.sum crates, heavy crates. I'm just going to have to borrow that. And lightweight, light volume, and light crates. And so function, and we want to get this, well, we're just going to sum up the crates. We can see that rather quickly. Sum crates and self, and this will be a crates. And we need a truck as well. So we need a truck and crates. Let's call it indexes. Indexes, whatever. And vec use size. And this returns a weight, volume. Sorry, this is an F64, F64. It's a weight and a volume it's returning. And this has to both be the truck, so this has to be n truck heavy and truck light. The reason I'm not making these member functions on truck is because I have to access the crates, and the trucks don't actually know about the crates. And we knew that because of the borrowing rules. And with weight equals 0 F64, and there's probably a way to do this, adding up. I know there's folding operators and stuff, but I can't remember them right now, so I'm going to do it the slow way. If somebody wants to tell me the quick way, volume and for I in 0 dot dot indexes weight plus equals how do I say it? So let current crate equal and self dot crates truck dot crates I current crate dot weight volume plus equals current crate dot volume, weight comma volume, and we sum them up. And so we have the sum of these two crates, and now we can compare them if they're any better. And the basic logic is right here. It's generic logic. And so we have delta truck heavy dot weight minus heavy weight, so everything in the heavy weight, plus the lightweight, minus the reference weight, the comparison weight, max of truck lightweight, minus lightweight, plus heavyweight, comparison weight. This is a comparison. See, is the delta going to be better if we make the swap of all these items here? And because it's random on both sides, it could be 0 to 4 on either side. And the volume is the same way. If we take the heavy, do the same thing, it has to be within the volume range, minus light volume. Truck heavy volume plus light volume is heavy volume. And these are good, and we're going to return some, but I want to sort first. How do we sort again? Sort. There's a sort function. Rust sort. I just want to sort the vectors so the outside thing doesn't have to deal with it. And or we just return them. Sort the slice. Should be the same. So we want to do heavy crates dot sort. We hope there's a natural ordering from 0 to high. And I actually want to reverse sort this. What does sort return? Is there a reverse? Doesn't matter. We're going to return the sorted crates. So it's going to be heavy crates. Light crates. And honestly, it's not this part that should worry about the sorting. It's the thing we're calling should worry about the sorting. So where do we do end swap? So we have an option. We have some heavy crates, kind of light crates. And otherwise we do nothing. And we actually shouldn't need the rest of this stuff here, except we have a fallback in case our random number doesn't do enough. Because 100 of them, we're doing 100 of them here. Let's do 10 to start with. Yeah, 10 randomly. And then we'll go back and do the iterative thing later. So we'll always just take 10. So what we have to do is we have to sort these things now. So for I in 0 dot dot. Now let's do sort. Let S equal heavy crates dot sort dot reverse. I hope that works. I'll figure out what it is in s.len. And we're going to do this moving around. And this has to happen on all of them. So these are all moves. So the current crate, and we're actually going to do a return at the end here anyways. The current crate equals self.crates. And this is the self truck heavy elements crates.I. No, SI. Wow, this is getting pretty deep here. And actually, let's leave it as P so we have clarity as before. Let P equal SI. And that's the actual index. Or no, wait, what's that? Because we have an index and an index. Can I just do this for P in S? Let's do for P and S, that should be fine. And we remove the one crate and we add it to the light truck. And then we do the same thing for the light crates. Now the reason why we need to do this in reverse order is because of the remove. We have to guarantee that the numbers don't change as we remove the crates. So we remove the highest crate first, and then the ordering doesn't change. And adding to the other side doesn't change the ordering either. So we're going to do this self trucks light, heavy truck light index. So there's still no borrowing involved. Truck light index, remove it from light one, and now we add it to the heavy one. And we probably have all sorts of errors. All sorts of errors, as I said. Unexpected. That was unexpected. Unexpected. Did you mean heavy crates? I did. 228 heavy crates. Light crates. That's probably the other errors. Oh, what'd I do? Expected integral variable found references. 186. Yeah, we can just do this. Expected I size, found U size. Why? 218. Why is light crates different? Because I typed the wrong thing. Cannot be indexed, so 187. What did I do wrong? 187. Current trucks I dot size. Truck dot crates I. Huh? Why is this an and U size? Okay, so I have a vector of U sizes. I'm borrowing it. I want to look into the indexes for each one, and truck.crates I should be fine, but it's not fine. Why is this? Why can't imagine I need that, but okay. Somebody has to explain to me why I need to do points to I here. Why do I need to dereference I? I'm looking. Does it automatically assume I want references because it's inside a reference vector? Like if I did this instead, would it actually work? Okay, that works. I'm still a bit unclear on this. Sometimes it does automatic dereferencing and sometimes it doesn't, and this is still confusing me a lot. And now we need to find a way to do a reverse. How do I get a reverse sorted list from a vector? This is the question. How do I get a vector to a slice? Coercing an array into a slice. Okay, I need to get an actual slice here now. What's the binding on that? Okay, so I need to actually put this in brackets. Alright, so I'm going to check that again, what I did there. So Winter Squirrel, you're saying this line 186, would this be invalid? For I in? It's not at this point. It's not a single use. We actually need to keep the vector around. We absolutely need to keep that in order. All right. What do we want? We want to do a... Where's your sorting? I thought you were giving me sorting code. You're doing the combination code. Excellent, excellent. Let's do that. Just mark this for now. Now I need to know how to reverse and creates is not enough. Thanks a lot for that, Iron Coach. We'll get back to it later after this random stuff works. Disk clone from size. I'm going to need a full syntax because I don't have a dist. I want a reverse slice iterator. Don't make me look this up. So I want a reverse slice from Rust. So just multiple steps. Well, I guess that would work too. I was hoping to use a... Are you saying it's just... So it may just be this last bit I have wrong here. No, Iron Codes, we actually needed to return every 1 combination, 2 combination, 3 combination, 4 combination, so it has to be a parameter. We have to be able to say which ones. Okay, so rev is still also not there. Alright, okay, this is just getting confusing. So heavy crates, reverse. It's not that bad. A generic combination code, it's not the most challenging algorithm, it's just kind of annoying to do. That's why I'm avoiding it. Alright, well thanks a lot, Iron Codes, for all the help. I think we'll do a bit further now. Like I say, we have the right to go see the senior bankers. So I'll apply for that offline just to see if we can actually go and see them. If we get a trip to Hong Kong to meet them, that'll be great. And I'll bring the camera. Otherwise, I'm just going to try and make this even faster now. And I'm still unhappy with this here, though. There must be a way to just get a reverse iterator on this sort of list. Maybe not. Reverse for vectors. Well, you could be excused from that, Winter Squirrel. When APIs are inconsistent, it's very hard to get it straight. Okay, well, the video, we'll see where we're going. Okay, let's see, what do I have? Cannot borrow mutably. Oh, come on! Stop it! But we can't borrow it. Okay, we're going to go back to mutts. Mutt. Come on, mutt. It looked like it worked. And we got a really low number, so it actually looks like it working. We're going to put it back in release mode, or was that in release mode? We have release mode, it's working. We get good numbers out of this. And we're not even doing many loops yet. So this is actually looking really good. And we have these fallbacks, we can leave them in. They're just a total waste. Fallbacks. Not strictly necessary. And let's see how many loops we do. We do 1,000 loops, and it's really fast, so let's do 10,000 loops. Let's see how small we can get this thing. Compilation took a while. It's taking a while. That's nice. Look, we've got an order of magnitude better. That's really nice. It's totally random, but that's okay. Let's see if it does better each time. This is very good. We got an order of magnitude better. That's excellent. Whether we get that on all of them, though, is the question. Well, let's just find out. Let's go back over to here. Let's just try it again. And we're actually going to have to get the other code on. We'll select a file. Now we have a new file. Coding game, the Great Dispatch. And we're going to have to do them all this way now in these subdirectories. Main RS. Upload file to IDE. That'd be tragic if I downloaded and overwrit the thing. I would cry. Okay, let's play test case. See if it all works. Not that we're missing a crate of some kind. And, oh god, it's compiling. I forgot its debug mode. So this is going to take a long time. So our current score is 0.6 up at the top there. 0.653. And this is going extremely slow, which is problematic, which might limit our approach this way. It's like to have a nap here. My goodness, is this slow. It's going to time out on us. Which is awful, because it didn't take that long in the command line on my machine. And if it's more than like 10 times as slow, we have a real problem. Yeah, okay, we ran out of time. That sucks. So we have two options to make it use less time. Let's take 1,000 loops. Was that still getting us decent results? No, it's not. So we may have hit a limitation here in debug mode. What else can we do? So we have 10,000. We can't go above 1,000. Their simple system craps out on us. We're doing 2 random trucks. Well, let's go back to these trucks. Let's see how good we do if we take every combination of trucks instead and do combinations of items. We do better with random trucks because we're getting stuck probably in local minimums. Or is that just because of the thousands? Oh yeah. See, it doesn't matter. We can use random everywhere. If we just keep bumping this number up high enough, we can use random everywhere. The problem is this is too slow. But it's really effective. And oh, crap. How do we improve this? Well, let's do it this way first. Let's try. Okay, now we're in a kind of the shitty mode that coding game is going to do this uncompiled or unoptimized. So we can't improve the amounts. And we're going to take 2 random trucks because I think it's actually better. It avoids the local minimums we're getting. So if it settles in a local minimum, we can get out of that a lot easier. And the find move, we're going to change the order this goes in. So this end swap one is actually rather slow. So we're going to take this end swap one and put it last. So if we find something else first, a cheaper swap, then do it. Otherwise, let's go for an end swap. So we get all the cheap swaps out of the way first, and then we go to the end swaps, the expensive ones, and that might speed us. That might let us get with a little bit more, and it gets us good value. But this is really slow. And let's run this in a time program. see how long this is actually taking. Okay, so it's taking 10 seconds, which means it's got a lot of weird output here. So 10 seconds is going to be too long. So if we do this in debug mode instead, well, ls target. Why would no, never mind. I'm just not trying to figure out why it's not an option. And we'll see how long this takes. I assume my machine is going to be faster than theirs as well, but maybe not, because this has nothing to do with memory. It's going to be raw CPU time. So if they have the same gigahertz machine, it should be equivalent. It has nothing to do with memory. And if I have dedicated resources, we have to get this down to under 50 seconds though. Or maybe now we should go back to the actual one and actually check the time. Does anybody know how to check time in Rust? How can I actually check the current time? Because then we'll actually do the 50 seconds then. Instead of guessing, we'll actually do 50 seconds. Rust time. Instant. It's taking forever in debug mode, so we're really screwed. Like, this didn't take that long in debug mode. I'm trying to check how long it is, and instant now. That's good. We can do instant now, and it's still running. This is a bad sign. Very, very bad sign. Let now equal instant now. I'm going to start. This isn't in some crate or something, is it, that I have to import? No, it's in standard. Use standard time duration, whatever, good. In my little machine, the fans are getting faster. Means one of my CPUs is going nice and fast. But I cleaned my fans, so you notice it's at 66, and something's running at 100% though. So I have two. I'm at almost at 300% total load, and so you notice my sensors are only at 66 degrees, whereas before I cleaned them, this one thing at total load was putting it up to 90 degrees. So my fan's actually quite good, but it's quite loud. I don't know if you can hear that, but it's keeping it cool. That's the main thing. And oh god, we're screwed. Debug is unbelievably slow. We're not going to have a chance. Okay, get you guys back in there. So we have some sled instance duration. Okay, no, I'm in the wrong file. So we have an instant now, and what we want to do is we want to do not for a while, we want to do while now.elapsed. Sure, let's do that. Elapsed as seconds. And I just didn't say less than 5 to just test if this works first. But I'm going to wait for this other one to finish. And this is a real problem. It's taking too long. Well, let's kill it. That means we're screwed. We cannot actually compete for much higher if I can't actually do this. Let's kill that. Yeah, we just don't have an option here. So we have more debug, and we're gonna give it 10 seconds. So now the new code says 10 seconds. Well, it would if I didn't make an error. Not found in the scope, so we had 10 seconds. Let's see how long it was. And now we have a direct comparison to see where we get with 10 seconds on release and debug mode. But it's going to kill us because I think our algorithm. So we get to 0.31 in debug mode with 10 seconds, and it's pretty close. Now let's see what happens if we do this in release mode. The exact same thing, the exact same 10 seconds. How far do we get? 0.3 we had before, and in release mode, so we're comparing 0.3. Where do we get in release mode? And, well, not a lot better. Because we're in 10 seconds. That kind of is shitty. Why are we not doing better now? Was I actually just running longer before? Oh, yeah. Duh. Thanks, Amorous. That would make a lot of sense. Okay, so we're getting 0.2, 0.3. Let's do release mode now. Let it run for 10 seconds, and let's see what we actually get. This is a lot longer than 10,000 loop we did before. It's never run for 10 seconds before. And we're just doing, and it's like an order of magnitude better. We just, I mean, what are we going to do to compete with that? Let's do one local test of 50 seconds. Well, I'm going to put it to 45 because I don't trust their system to be 50 seconds, to be fair. And so we'll run it twice. We'll run it once in debug mode. So this is debug target. I keep putting it clear and cargo build time debug. This is all debug. So we're going to let it run for 45 seconds. And we'll see how well we do. It's probably just an oversight in their fault, but there's the old thing. I don't know why they just... well, maybe they need an option, because if you're coding on the website, you don't want to code in debug mode, because if you get an error, you have no idea where it is. But given their tiny window, you have no idea where it is anyways. But this would be really helpful for this, because all of these ones, as you guys say, all of these algorithmic ones, the competitions and everything are going to be horribly limited by this, because the speed difference is just so unbelievable. And we'll see how well it does in 45 seconds, because we can still submit it this way. And it's probably improve our score a little bit. Windows scroll, I think they do, which makes it horribly unfair. And each language optimizes different, but since they do, and C++ has wonderful optimizers, you just can't compete with them. So okay, so we get 0.08. So if it runs long enough, the debug mode can actually go fast enough. So 0.08, keep that in mind. I need to do a clear here, 0. I'm going to write this down. We had a 0.08. And now we're going to do it in release mode and let release mode run for 45 seconds. And as long as this isn't stable, as long as we just keep finding random things, we'll see what happens. We should get a better score. And if this does better, it makes no... Okay, yeah, that's actually really helpful when you have debug. What C++ also has, which makes it faster, is in their libraries in GCC, they have a lot of their functions marked forcibly optimized, like the vectors and stuff. So even if it is in debug mode, some of these things are still forcibly inlined, even in debug mode. And I'm guessing Rust just isn't at the maturity to have that yet. And so this is like the value's quite a bit better. Well, let's submit this anyways. Let's just submit it and see how much better we get. Our total score now is 0.65. And we're just going to submit the whole thing. I assume it's going to run. And this will take exactly 45 seconds now, or 40 up to 60. And well, let's see what this happens. And there's just jobs here, and you can't open this. I'm afraid to click this now when something's running. Okay, but yeah, I wonder if there's an equivalent for Rust. I'm guessing not. It's actually really strange to have pragmas that optimize that in C++, but okay, that would work. And there's no point in taking your approach right now. Like right now, we're just taking random subsets of the crates and comparing them. your approach of actually iteratively checking all the combinations is probably actually going to be slower. And so this is our old weight, so let's go to try again and see what we have. It's not showing me a score at all. It's still computing. If inline always was respected, which would certainly help a lot. Okay, so we've improved our score a bit. We've gotten down to 0.321. And this is in debug mode. We can look at optimizing. There's lots of things we could optimize. I don't know how much it'll actually help. Let's check where we are now, if that pulled us up in the leaderboard. We were at 121 before. I keep typing the whole name wrong. So that brought us up a little bit in the leaderboard. Why do I not have to check all of them? Just looking at this to see if this makes the... I'm just trying to figure out what your approach is actually doing here. So are you just earlying out? The moment you figure out the weight's too much, you just do an early out and you cancel that. I mean, I'm not doing the early out, but I don't think that's what's killing me. What's killing me, if I had to guess, in its terms of the memory, is this function. I understand what you're doing. You're sorting them by weight and only comparing them close together. That may or may not help, but I think I say what I think is killing us the most right now is this function right here, getRandCrates. This creation of the vector at the end. This is a borrowed vector. It's actually dynamically allocated, and it's going to return each time. So this is always allocating new RAM, and it's dynamically sized. So I think we can improve this first of all. So let me pump up this time back to something reasonable to test. We're going to do 5 seconds to test here. And I'm going to have a baseline. We're going to do it in release mode. No, in debug mode to see how horrible we are. And see if we can do better otherwise. It's a 0.43. This is kind of random though, but we're going to take it. And what we're going to try and do is see if we're getting rid of this memory allocation makes it faster. So getRandCrates, we're going to give it a crate now. I'm going to give it a vector to reuse. And... oh crap, we can't do that though, because sample iter returns a vector. So this gets really hard to use, but okay, nevertheless, let's do it anyways. Let's try and optimize this a little bit here. And this is a mutable vector. We're going to actually clear out this vector. So vec.clear for in 0.count. Is there a contains function? Vec.contains, I'm going to hope so. Let's do this. Let RNG equal rand thread RNG. And we can probably improve this even more. The count, and we're going to do a count. We're going to do, what was the other one? And and let p equal range dot gen range 0 comma self dot crates dot len, somewhere in that range as a use size. And if it already contains p, we don't. Something if vec does not contain p, vec dot push p. It may not be count, but it'll be up to count. We're just going to take it random here, and it has no return, so we're going to say get rand crates. And so we can do this. We can put the vector out here. Vec new. So at least it can reuse this. So we save a little bit of time here. And done in a tight loop, this helps a lot. And if this helps, it means we just keep moving this further and further out. And it's one of the things I had to do in Java a lot, because Java allocation, C# allocation is really shitty, and they're really bad at it. You have to avoid memory allocation. C++ is good. I thought Rust would be good, but Rust in debug mode may be bad. I assume Rust in release mode is good. And well, we'll see how that works. Truck heavy.get rand crates. And mut heavy crates. Truck light.get rand crates. And mut light crates. Let's see if this actually helps and if it compiles. Count, okay, 50, that's fine. Unused duration, fine, let's get rid of that too. I don't use duration. Vector. Why is it? No. This is stupid. It should not be expecting a borrowed. This is wrong. I'm not putting borrowed values into the vector. This doesn't make sense. Cannot borrow mutably, that's fine. 8, whoops. Let's see if this does any better. We gave it 5 seconds, and we get 0.43 before. And, well, it's random, so it might get worse. That didn't do well at all. It's doing far worse, which is not good. But maybe because it's returning the wrong stuff. ePrint. Let's just see what it's printing out. I don't trust this anymore. I don't trust it's actually giving us good values anymore. Well, it's still giving us decent values. But it's getting slower. Why is that? Why would this be slower? And I think it has to do with the silly and p here. Because we have a vector, I just don't understand. I really don't understand why this is and p. This is a mystery to me. This vector contains use size. It does not contain references to use size. It just contains use size. So this made it slower, which makes no sense. So something broke it. I don't know why that makes it slower. Clear the vector, count it out, get rand crates. I don't know why this makes it slower. In theory, this should make it faster because you have less allocation. And maybe it optimizes it wrong, but that doesn't make sense because it's not running in optimized mode anyways. Oh wait, no, it is better because the value is 0.43 and we're down to... Okay, sorry, this is faster. Never mind, this is faster. Not a lot faster, about twice the speed though, but twice the speed will take. And so this is getting average faster, so that's good. It is actually faster because I was just comparing it. I thought I had 0.43, but I have 0.43. And if we just want to double check that again, we can do this. Let's just go back and verify that it is actually faster. Get. Oh, where'd I go? And we'll make a second one here. Get rand creates v and self is a vector usize. And this just returns that. Get rand creates v. Get rand creates. And so this is get rand creates v, and we're just going to compare that it is actually faster. And if this does actually make that much of a difference, we're just going to keep pushing it out further and further and reuse the values a lot. Count, I forgot the count, okay. And this is very standard optimization type stuff. They just avoid allocations. It's not the end of the world. We'll make it fair and actually just reuse the mutable here. And just say and mort-ora-y. Makes it a little bit fairer. Okay, 0.22, that doesn't look like much of an improvement now. So we're not getting much of an improvement now that I changed that random number generator. So maybe it's the random number generator that's really expensive to create. That's possible. If the random number generator is expensive to create, we can fix that. Right, so it may not be the vectors. And this is the thing I don't like about Rust, is there's no way to create a global random number generator then. It doesn't like global values. We tried to create a global last time because I absolutely wanted one. And I'd love to have a global random generator here as well, but I just don't know how to do it. And so that means I'm going to have to pass it around a state. So it wasn't actually, this confirms it wasn't actually the vector allocation that's heavy. It's the random number generator that's heavy. So we can fix that a bit. Self. We're going to create a... We'll put it in the state then. And what type is this thing? Anybody know what type this is? We need a RNG or something. An RNG, I guess? We need an RNG... And we want to have this a rand RNG. RNG is going to be rand thread range. And get rand crates, we're going to stick this inside the state then instead. And no, we can't. Ah, damn it. We can't because range generator is mutable. And we're not an immutable function, so we can't do that. Oh, this annoys me. This is... How do you... So we don't pass that down. We pass a... Pass down an RNG as an and mut rand RNG instead. and we have to pass down length. Len is a use size. Move the use size. No, len. Len not count and get rand crates v. This will be now dot self dot get rand crates dot v. And mort-ora-y truck heavy dot crates dot len. This is actually kind of shitty that I have to do it this way. It just makes the code more complicated. I'm gonna have to pass this around. Truck light dot crates dot len. Because this function is going to need to take the same thing now as well. And range is going to be an and mut rand range. Find end swap is going to be that as well. We'll do that. And where does find end swap come from? Find end swap. And we can pass an and mut range here because this is a mutable function. Cannot find value. Let's do 274. 274. Default. So we don't need the default anymore. We're not using it anyways, so it can just go away. Random range static does not have a constant size node. What the hell? What does that mean? Inline always. We're going to figure that out. Okay. No, doesn't like that. Cannot be invoked in a trait object. What does that mean? Without this, I'm using a fill and then swapping. And what now we're competing with right now is that coding game doesn't run it in release mode. So I'm going to have to find ways to improve the speed without going to release mode. We're currently at a score of 0.321. This is our current score, which means our algorithm is basically working, and the longer we let it run, the better values we have. So, okay, so thread range. Okay, so wherever I put range, this has to be thread. This probably has to be thread range as well, I guess. Get rand straights. Get rand crates v. Get rand crates v. That's there. Oh, it doesn't need to be self. It just needs to be get rand crates v. No self anymore. Well, what's its problem? Okay, I understand, Ever, so that's just more of a trait then. Let's just stick this outside somewhere. It's a generic function. Let's try this first. Otherwise, I'll try your syntax after. If this works, we'll put your syntax in. Because I think it's nice. Cannot borrow immutable argument. Where is that? What? So now it's complaining here, it can't borrow this mutably even though it's mutable up there. I don't get it. I just get confused sometimes. Okay, now I'm really getting confused. Why is it not a reference though? Why am I... I'm going to see this again. I'm getting really confused on that. Found keyword mutt. Well, I can't remove the... Okay. So you're saying the whole thread range is like already mutable? I'm thinking it's not though, is it? Let's go back here. So this doesn't have to be mutable at all or something, I think is the idea. I don't know anymore. I really don't know why this works in some places and not in others. Why can I suddenly pass range around? That doesn't make sense. No, I can't. It has to be a reference now. Ugh. Is this supposed to be mut range, and mut range? This is really getting frustrating. It's happy with that. But this has to be a reference. This just has to be a reference. Found reference. It's supposed to find a reference. Well, that's what we were doing the first time, but I can go back to that. This is what we tried the first time, and what it was bitching about was just lag. Lag is wonderful, isn't it? It's twitches. I mean, I don't know why the lag is so bad. I mean, I don't know what they're doing. I guess it's... Okay. See, look at this. Look at this error right here. Oh, this is very slowly. We have this error right here. And that's for this code up here. It's saying sample iter can't use this. Cannot borrow muted. What if I just stick range in? Okay, so we're going to go 209. So this is supposed to be an AND mut. And so it keeps the type. So range is already an AND mut. Okay, so 273. Self.range. So you can have immutable reference all at once now. Oh, come on. No. You get the same shitty error again. I'm really distressed by this stuff. I mean, like, It's so frustrating in Rust that basic algorithms you just can't implement. It's already borrowed mutable. I understand it's borrowed as mutable. That's why I want to make it mutable. I want to use the self-random generator. Like, I suspect we're going to get this error, and it just like sets us all up for nothing. I mean... Is there any way to do this other than restructuring this whole thing again to make one step that's a immutable and the other type that actually does the modification? Like, if I have to do this as random number generators, there must be a better way to use random number generators. I shouldn't have to pass these things around through every function. How on earth can I do this? Well, I can just do this for now. Rand thread RNG, and this is absolutely not what we want though, because this defeats the whole purpose of what we've done. Yeah, probably. But this, I mean, this works, but it defeats the whole purpose of doing this. I mean, the whole purpose was we have one random number generator because we know that's killing us for time. But I can't get rid of it. They're just so hard to move this data around. Which makes it, and it's actually going slower now. You know, there's a good one there. I just don't know how to do that. There has to be a way to create a global random number generator. I don't really want to undo this, but it's the only way I can do it. It was going faster before. How? Swap trucks. I know I can get this out of this. Just shit. I mean. I don't know what to do in this. I just don't know. I mean, every time I attempt to optimize something in Rust, it just tells me you can't do that. And it's extremely frustrating, and there's no clear way of how to get around it. I have an object, and I have one borrow mutably inside the object, and it just doesn't allow that. And I really don't know how else to do that. I can just make it even worse. Let's just do it the worst way possible. Let's take the random number generator out of the state. Yuck. And just give it down here. Is that what I called it? Thread RNG. And swap tops can have it as well, swap trucks. RNG, and this is a thread range. That's the type it has. And so we just pass it down here, it already has that type. And this means way at the start of our start program, we're going to have to pass it in here, so let's do this. Let RNG equals rand thread RNG and mut RNG. Okay, so no. Okay, 243. I don't remember, what was their thread range? How do I create these things again? Rand thread range. Rands, and this was also in, we don't need that one anymore. That one doesn't exist anymore. And this just becomes range.genRange, so that should be better. Range.genRange. $349. See if we get better results, if that actually makes it faster or not. That is better than locally, but it's not a lot better. It's not really that much better. Kind of sucks. Let's see if I submit it, if it actually gets better. Submit this, just go for it. We'll see if this gets any better. That was a lot of work though for a very minimal gain, and it's forcing us to change the structure of our code, and it's forcing us to pass a variable down, which I'm very much opposed to. If you ever see any other code, I think anytime you pass a variable down through multiple levels, something's wrong, and you should never actually have to do that. There's a very few special cases, but this is what globals and singletons are for, and there has to be a way to use them in Rust. Last time we tried to do it though, it didn't let us create a global singleton, it got mad at us for it, and said something about lifetimes. We have to worry about lifetimes, and I'm not sure how to do it, and we'll have to see what's going on. Let's see if this gets better. If this improves our result, say we had 0.321 before, anything better than that, but again, it's totally random. What improves our result the most is just by increasing the number. So this was our previous one. So if we try it again, we're going to see what we are now, and that's not possible. This is not possible given the randomness that we actually have the exact same value. Well, let's check that, because that would be the only possibility. Did it lose the connection? It did. We lost the connection somehow. So we lost the connection. That would be the reason why we have the exact same one. Okay, so now we have that. So let's submit it again and see if we're actually getting something faster. And doing these little optimizations, I mean, if we can get it going, if we can get a better score in the debug mode, all it means is if we can ever actually get it compiled. Now, I think we did actually submit the old code, or did it actually do a better code? It could just be random. Do you know if I submit something with the worst value, does it just keep the one that had the better value, or does it keep updating randomly? Let's see what happens. That was definitely the wrong code, because we lost our connection, and probably because, yeah, this is why we lost the connection. It's not the fault of this plugin. It's because every time you submit, you leave the editor and we leave the connection. 0.03. Okay, but that's probably just the randomness. Okay, so that was, but this is because, remember, we're totally random. Every time we run it, we're going to get a different value. We're expecting something a lot better than that. See, now it's actually computing as well. Let's see what we get. I want to see how much time we gain by sharing that random number generator. Because every additional second... And... Is it still updating? Or is that still the old score? Best. This is the best score. Does that mean if we've gotten a worse score, we won't see it? Okay, so we got a worse score this time. So scrap that approach. It doesn't make enough of a difference to actually make it worthwhile. But we can just keep submitting. So we could actually just, we make a bot to keep pressing submit all night long, and eventually we're going to hit a better score. I'm going to undo all of that work I just did in the most horrible way possible because it buys nothing and it's awful in the code. And we'll have to find another way to optimize it later. And at this point right now, oh, okay, so they thought about that. We'll hire one of those Indian services that just go through the CAPTCHAs for us. Get rid of all this randomness. Right about now, I'm wishing I actually would have submitted the code to Git so I know which version I'm running. But I don't know what we can do in release mode. And I think I'm pretty close to done here because there's a lot of stuff I know we can optimize. And I don't think algorithmic optimization is the best option at this point. I think it has to do with the vector stuff. All of these vectors, all this allocation, and all the stuff we're doing here is not giving us a great approach. The end swap we do last, we find move. We know move is the fastest. We know swap's the next fastest, and then find end swap is the slowest. So we do them in that order. In case we find something first, it'll be faster. But at some point, find move is never going to find anything. So we're actually wasting a time. At some point we're wasting our time here. And same with find swap. At some point we're wasting our time on find swap as well. So I'm wondering if maybe we shouldn't actually have some sort of indicator saying like, once we've hit a certain limit, just stop executing these. Yeah, that might actually be reasonable. Well, let's actually try that. Let's see if we can improve it that way a bit. And we'll just kind of guess. And we're going to have an iteration, which is a use size, and we're going to pass this down to swap trucks, the use size. I mean the iteration. And what we'll do is we're just kind of swap trucks is going to take a iteration, which is a use size. And we're just going to say as long as how many iterations do we do in total? And we don't know anymore. Let mut iter equals 0 I32 or use size. Swap iter, and then iter plus equals 1. Where I see that again, iter. And if it's less than 1,000 iterations, we'll do the move. Because we know the move is only good up to a certain point. After that point, the move just does nothing. We don't find anything. And if the iter is less than, let's say, 2,000, we stop finding swaps. You're just guessing the values. If this actually works, if it indicates it might be faster, we could actually start testing stability values. If we're within a certain range, if we do a loop and it doesn't gain us anything more, so what we can do is keep doing find move until there's no improvement. Then we keep doing find swap until there's no improvement, and then we do find end swap. That will be an option because we know that they're each different speeds, and we do the first ones fast, and then we can cut them out later. And I put this back to 45, and this is 5 seconds. Did I submit a 5-second code over here? Is that why we had such shitty code? No, it was 45 seconds. Hard to say if this is faster. We're not going long enough. it actually looks to be slight improvements. Let's play with these values a little bit. Let's say the first 100 iterations, and only the first 1,000 iterations for this one. Because I forgot each iteration does the full num truck, so it's not really helpful to do more than that. No. Or maybe it is, maybe it isn't. Your numbers do appear lower, and if I put the numbers low enough, we can confirm that these algorithms actually do help us. They do get us speed. Because if we just do the find n swap, it ends up being too slow. We get very little swaps done. Right, the n swap is horribly slow. So let's say first 50 and first 1,000 then for here, and then the rest do n swap. N swap is our general purpose one. Given enough time, n swap will eventually find a good answer. And this is actually looking a little bit better. And if I wanted to improve this, I'd actually put stability on here. So these can keep doing find move. And find swap. They're a bit faster. I don't know. So it's really, and as I say, the find swap, I don't think it's the iterations killing it. I think it's the actual vector. And so going to Euler's approach of just actually going down to depth of 4,4, I don't think will actually help, because I think it's just going to go slower. And what we could actually test though here is that something he couldn't do is ran crates. We just go down to 10. Let's see if swaps of up to 10. It seems ridiculous and probably not going to help. But we have a very easy option to do this. And it probably doesn't help much. Nah, it's not helping. So it's not worth it. And let's try down to 3. It's a bit lower. Let's just do 2. No, it has to be an upper limit. So this will do down to 2 by 2, and we'll see if that makes a difference. So it's a really small difference, and we're really just going to have to catch it in a good location. So 5 made sense, because this is actually 4, it's not actually 5. And this should actually go to 0, though, because we actually want to sometimes do a move, because we said move would actually help as well. Occasionally we get a 0, and you might move one, but at this point in the game, probably never do get a 0. By the time we hit n swap, it's probably highly unlikely that a 0 move is actually going to help. But if we could just run more iterations, it wouldn't be a problem. It's a lot more stable. So let's put it back to 1 for now, because we have the move swap. And let's put it back to 45 seconds. And let's see if we can actually, let's see if this actually makes a difference over here. We need to update the new one, and let's submit this one. Let's see if we do any good in this one. So it was 301 was the last one, 0.301 is the best. I guess I don't have to write these down because we found the history board. And we'll see how long this takes. I'll see how well we do, and then I'll call it a night. I should be back tomorrow night as well. I won't be doing this one because there's no point in just fighting against the optimizer at this point. We might as well start another one, and I think we'll try one that maybe has graphics again. Maybe we'll leave the compete and go back to practice for a second. I don't know. I'll think about what we do. But we did a lot of progress today, so we got far enough to get in touch with the banker. And we'll click that button afterwards. What happens if I click it now? I see I leave that place, and that's what I was worried about. Apply with LinkedIn, it's in London. London, no, it said Hong Kong. I want to go to Hong Kong. And it's Bank of America Merrill Lynch, and they've removed the description here. kind of removed the description. It's 30 days. Okay, and well, let's just go see what we got for a score. Oh, it doesn't like us. It does not like you going back to this screen. I don't know what it's doing now. Alright, it didn't like that at all. So coding game, something's gone weird with it now. I want to see what value I actually got last time. We couldn't have got the exact same value. It means we got a worse value. So we got a 3, 4, 5. So we're just kind of fighting with the optimizer. We know with an optimizer we get that push higher. And you don't actually really want to optimize code in debug mode unless we can find something algorithmic or reduce the algorithm complexity a lot. And I don't know how to do profiling, so I don't think we're going to get it a lot higher than this in debug mode because it's just so awfully slow. And maybe some trickery to get it half of this, but half of this is still not that exciting. I want to get it down to, if we can't get another order of magnitude, it's not so good because we know the leaderboards are an order of magnitude. So we're going to have to sit at 92 for now. And we'll put a comment over in the coding game forums that we really want release mode for Rust, because otherwise we don't have a chance. But we got up to 0.301, which is pretty good. I mean, we were at 99 when we started the show early today. All we did was implement the one swapping, the move swap, then the 1-1 swap, and that got us quite far. That got us under 1. And the n by n swap, the random amount, got us half that, got us down to half. So we're at 0.65, now we got to 0.3. And that's pretty good. And we need more to get that. So I thank you very much for watching. I should be back tomorrow night. I don't know what I'm going to do on it tomorrow night. I don't think we'll keep doing this one, but we'll try another one. And I'm pretty happy with where we ended up. We've got a good rank here. We're number 92. And like I say, if we just had release mode, we know we'd jump up quite high in here because the values are quite a bit different on the command line. That's my show for today. Thank you for tuning in. Please remember to subscribe and to retweeting my posts or post it on your own shares. This will be up on YouTube and Twitch. Make sure to follow all those great things. It helps me out, gets more people in the show, gets the awareness there. And I thank you very much for watching, and we'll see you tomorrow night.